Okay, then let's proceed with Benedikt Koehler and street fighting trend research. Welcome.
Thank you very much. So, okay, this works. Well, this talk is about street fighting trend research. That is how to apply various methods of data analysis, very much, of course, Python-based, to data sources that have some kind of information that gives you trends about cultural lifestyles, about brands, about technology. Just a little bit about myself. I'm no traditional programmer. I'm not even a techie. I'm a sociologist, but I've been doing some web programming as a pastime since the 90s. I've been programming mobile applications, then interactive social mobile applications in the 90s, while it was only based on the WAP protocol and was so costly to use these applications that they never had a chance, but was really fun. And then I studied sociology, and I did some research projects on statistical data visualization in the 2000s. And then I started to delve into the blog research. Today it's called social media research. Then it was called blog, because blogs were the only thing that was around. And I built some kind of blog recommendation engine in the 2000s, and it was called MetaRole, and it just looked into the blogs, the blog role you had on the right side of your blog. You had other blogs you linked to, and it just built some kind of recommendation graph from this, and it gave very interesting recommendations. And then I worked at the social media intelligence company Authority, and now I'm in Munich. I have a company called Decor with two partners, and we're doing data science, market research for media and advertising. And you'll find the Python code I'll be showing later on my GitHub account, and also giving you the link for the presentation later. But first, the focus. This is a very famous data science Venn diagram by Drew Conway, and normally we have to be here because this is where the topical expertise, the math and the hacking skills come together. When it's about trend research, I think we're more in the danger zone, because that's where all the fun is. Because today I'll focus on more the hacking skills, on how to get data that we can use for trend research, and of course a little bit of background and what's the state of the art in trend research right now. So the title "Street Fighting Trend Research" is of course heavily borrowed from the Rolling Stones. Had a singer a long time ago, and then there was this great book on street fighting mathematics, and Pete Skomorock from LinkedIn has a beautiful talk on street fighting data science, and I thought, well, I have to go one step further and do some street fighting trend research. And basically it's about using data that's already there and doing various things from this. For example, using the geo position in tweets to find out the movement, the speed of the movement, and also to find new use for old or methods that are coming from other fields. For example, I'm doing a lot of applied research with genome sequencing software in advertising research. It works very well to identify different strings of behavior, which could be gene sequences, but also could be surfing behavior on the web. And of course, a lot of ad hoc research to find out, for example, at a political event, who is referring to whom and on Twitter, and to find to give you a network diagram. And it's of course, a lot of it is improvisation. A lot of the code will be quite improvised. And of course, publishing your recipes. It's especially when it's in advertising and media. There's a lot of secret sauce. There are a lot of companies who are doing predictive modeling, and you're paying a lot of money for it, and you never see the classifiers they were using, just a very vague description of, well, this is using a lot of very, very high and complex regression things and so on. So I think it should be open and should be free. Basically, I think the topic predicting the future is kind of a misnomer, because you cannot predict the future. This famous quotation that has been attributed to various people, for example, Yogi Berra, is predicting the future is more or less impossible, or predicting is very hard to do, especially if it's about the future. But there's another side to this, and there's a very nice quote by Mark Twain who says, the past does not repeat itself, but it rhymes. So there is no direct connection between the past and the present or the future, but there is some kind of a rhyme. And to find the rhyming data, that's, I think, a very nice description of the quantitative trend research, to tell stories about possible futures and developments. And there's also this quite influential paper by Hal Varian from Google and Hyung-Yong Choi about predicting the present. Because in many cases, it's very great if you even can predict the present. And here's some example from this paper. It's about predicting the sales figures for different automotive companies by using Google Trends or Google search data. And for example, you see this is how it first was, and this is then the model when it's applied, and actually it fits very well. And well, you'd say, well, of course, but I know Toyota doesn't know how many cars it's selling, so why do they have to look at Google search? It's the same as using some kind of predictive algorithm to find out that the weather's quite nice outside. But of course, there's a time lag between the data. So the sales figures are coming in quite with a time lag. Just if they're very fast, then they come 2 months after. But the search data is available 1 day after. So you can say how this curve will develop with 2 months earlier than before. And of course, there's if you're working with official statistics, for example, there's a lot of great data sources, open data sources right now about the employment, for example. And there's a time lag, of course, and there's also this kind of retrospect revisions. There's every half a year they revise all the numbers in the past, and this is really kind of tedious. And if you have some other indicator that's very well correlated, you don't have to rely on this or wait for the revisions. And sometimes the data is quite cheap to get. For example, Google query data is a bit cheaper to collect than to make large projections about the workforce. When we're talking about trends, there are various kind of models. What kind of different trends there are. This is a German diagram, because I think that the German trend or future researchers are very well at developing very complex diagrams. I didn't find one in English. So there's of course these very fundamental changes. They're called the mega trends, like the population that's aging, or the climate change, or urbanization. We're not focusing on that. That's not really something you can react to, or we're focusing more on the local changes, on trends, the normal kind of trends. For example, the rise of messaging or blogging, and then there's this kind of wild cards, things that suddenly happen and change everything. Like 9/11, but I think also the invention of the iPhone, or the touch screen principle, was some kind of wild card. And this is the most interesting thing, and the thing where you find most practical applications are these kind of weak signals. That is the first signs that there's something that's changing, and there are Elina Hiltunen from Finland wrote her dissertation on this topic, and there are some very nice indicators to know if there's a weak signal around. It's if you're saying something at work, for example, well, in 10 years, everybody will be using a smartphone to be social. And if all the other people in the office are laughing and saying, well, no way, then this could be a weak signal. That's a very typical reaction to a weak signal. And this is what we're focusing right now. And she did some, quite old-fashioned, or the way you did research for many years. You asked people, you asked experts, you ask future researchers where they get their trends from. So, and this is what they said when it comes to society and culture, and this is for technology change. And there are some data sources that will be covering. It's what scientists, researchers are doing. It's obviously a very nice source for changes in tech. And what ordinary people are doing. Well, great surprise. That's a good signal for changes in society and culture. And if you're interested in trends, of course, the books by William Gibson, especially the book Pattern Recognition, is a very nice literary description of what it's about. And nowadays, it's not called trend research, but it's cool hunting. And here it's the people. It's Casey who has a special sense to find out that something is changing, or that some brand could be very hip in the future. And now we try to build a Casey out of Python, more or less. This is just some very influential papers that give an impression of what is possible right now. Of course, one of the milestones has been the research on predicting influenza epidemics by search engine queries from Google. And they just identified the search queries that really fit very well to the medical data. And then they here's a nice visualization of the black line is the model, and you see it's some days further ahead. And this is kind of, these 3 days can be very valuable if you're talking epidemics. And there's another paper that's quite interesting from Kira Radinsky from Microsoft and Eric Horwitz from Tel Aviv, about how to mine the web and find out future events. And they are working with news archives of the New York Times, and they're extracting kind of event chains. They are saying, well, here is some kind of a political unrest, a local rally, and here's another rally, and then something happens, some scandal in politics, and they're chaining these events together, and then something happens, for example, a political change or revolution, and then they're trying to fit their models on these chains. And actually it shows that some things are harder to predict than other things. And here's a very, very large difference between the precision of these models, that is how many events they predicted were really happening, and the recall, how many events how many of the reported events that were correctly predicted. But there are some topics where this model seems to work quite well, when it's about riots, for example, but diseases are a bit more difficult. And then finally, there's also a quite nice approach by Stanislav Nikolov, how to find out trends. This is how things really look in the when you're doing a time series. And he's aggregating all these different curves. And then if you have a if you have a real observation, this line, then it tries to, every of these lines, for example, this is really a trend. This has been a trending topic. Then it says, well, yeah, it looks a bit like my curve, and it votes, yeah, this is a trend. And maybe other curves voting, this is not a trend. And then in the end, he gets a result, and it's not by fitting some model, but by like a comparison of the actual curves. So this is also a quite interesting approach. And of course, there's been cool hunting in the web. This is a really huge topic. This is a bit old article from 2007 from Peter Glor. And for example, he's identifying influential users on forums or on Twitter. And he's using some methods from social network analysis to find out who's really influential, who's really linking many people together. And then he's drawing the influence over time. And he can also say, well, this guy here, Jan, is really rising in influence. So it will be interesting what brands he's talking about. Of course, there's quite a lot of tools available if you're doing a kind of qualitative trend research, and many companies we're talking with are quite surprised that there's really this wealth of data. For example, Google Trends, it's really being refurbished every month, and it's actually quite nice dashboard on what's happening in the world. For example, it gives me the hot searches, it gives me people who are trending right now. There's the speech in northern Germany that's trending. There was nice weather, I think. And it gives me some charts. And of course, you can do a lot with Google Correlate, where you can basically just draw any kind of curve, and then it searches all the Google search history and gives you something that really correlates well. And this is actually quite fun to find out all various fake correlations. For example, here, there's a very long line or a very robust correlation of statistics and vegetarianism, which seems to be really with a R of 0.957, which is quite high. But of course, this is the way statistics, all our professors, teachers taught us not to do it this way, but actually it's the fun way, and you have to have some kind of subject knowledge to find out whether this is true or not, or what's behind this correlation. Twitter gives you some kind of insight on trends, gives you the trending topics, which is also quite nice. There's even trending locations on Foursquare. But, and of course, you can look at conference programs to find out which topics are being discussed in tech. But all these sources, which are really nice, they give you no access to the raw data. They keep it behind a closed curtain, just give you a dashboard. And they give you almost no context. For example, if these, you take a look at the trending locations in Foursquare, you don't know who's behind these trends. You don't know why they're there. And they're, of course, they're closed source. You cannot customize the parameters. For example, what is a trend? What are the different thresholds you should apply? I'd love to apply some other thresholds to the Twitter trending data, but I can't. And often there's no API, so you have to type the values, or sometimes you can export the CSV data file. And of course, the right topics are quite often missing. For example, doing a lot of work for fashion magazines, and when it comes to fashion, all these tools, they're not really valuable. For example, Google Trends, it's nice, but for fashion, it's not that interesting. So this all calls for a do-it-yourself approach to find some alternative ways to get some data and take a look at them. So I brought 3 examples which are really kind of true to the street fighting spirit. There are no clean code. They're quite hacks because we said we want to be in the danger zone. And the first thing is to find research topics from the web, to find out what's the cool trends in research right now. The second is to find out some kind of an automated mining of conference proposals, to find out which talks you have to visit, so you do not have to read all the programs. They are often very long. And if there's an algorithm to do this should be fine. And the third example is to find some trending locations on Foursquare and to have really the opportunity to tune your own parameters. So this is kind of on the GitHub. There's 3 IPython notebooks, and the first example is showing how to mine research papers. There's, of course, if you want to know what topics are really hot in, for example, machine learning right now, of course, one thing would be to read all the papers, all the journals, but this is very, it's a lot to read. So, and often you don't know where are the really interesting topics. So I thought it would be nice to take a look, for example, to have the hypothesis that what people at Google are doing right now, that this should be quite relevant, should be interesting. Here we're focusing on the research that's done at Google, but could be any other company, could be any other journal. Basically, the process here is always the same. It's to find out, is there some kind of data source you can use, get the data, then clean the data, build some kind of a corpus, and then do some analysis and visualizations. I hope you can see this from the, no? Okay, then try to do it a bit. So this should work better. So I can see it on my screen, so it's a bit difficult. So this is from the Python Natural Language Kit documentation. This is kind of the steps you're working through. If you're interested in more detail, then NTLK.org gives you all the interesting background. But I'll be focusing on the applications of this. So the first thing is to build our corpus, and I said, well, it's interesting to take a look at the Google things. They have a web page, research at Google, and you can see, well, it's a lot of publications on various topics. This would make really a nice corpus to find out about all these papers, and it's very interesting stuff on mobile, web, and so on. So the questions that could be interesting are, of course, what are the hottest topics right now? What are the buzzwords? Maybe this could be a buzzword bingo generator. You can do some text mining, and at the next conference you got all the needed buzzwords without knowing anything about the topic. Then it could give you an answer to the question, where are the new developments happening? What are the trends in this industry? What journals are interesting? If I have to read one or two, which should I subscribe to? And who are the most influential researchers, to kind of find out their GitHub repositories, take a look at the code. And here it's kind of the very raw street fighting approach to take a look at the web page source, and then use the beautiful soup parser and find out all the links. And but of course you could also look at the web page index. You could look at Scholar, Google.com, and well, here in this case it gives you very nice links for the different categories, and then you can take a look at these categories and then get all the the paper titles and the abstracts, and or the links to the abstracts, and then you have to do some cleaning. There is a lot of white space in the titles, in the abstracts. There's a lot of new lines, and so on. So you want to make sure that it's a bit clean for later, for processing later. And then you could, for example, take a look at the titles. You split it into a list of the words, and then you want to remove some stop words, because a lot of stuff is about my, I, ours, and so on. So you do not want to know about these words. They're not interesting. So you filter them out, and you get a nice list of really significant words. And then, of course, you can do just a very simple frequency count, just do a count of the words. And here you see first the words. If you have the stop words included, then all the top words are not interesting. Just the last one is about learning. This could be quite interesting. And the second list is without the stop words. Here you have learning, search, using web data, online networks, Google models, social. So it could also almost be a title for a talk, learning, search, using web data online. That's very cool. It's the list of the most frequent words appearing in Google research papers. Maybe this is kind of this is done by them for us to find out here. Then you can find the collocations. So it's not the single words, but the combination of the words. And this really is a lot more technical. Here it's about large-scale machine translation, neural networks, speech recognition. This is really kind of a buzzword bingo, giving you all the things, and also could be a title, large-scale machine translation neural networks. That's very nice, would be a nice paper. And then you can, of course, do some things like stemming. That's, you have, especially in the text, you have a lot of all the different variations of learning, learned, learn, to learn, and so on. And this Porter stemmer, for example, it's really implemented with a very clean API, of course, in the NLTK, the natural language processing toolkit. And it really transforms your data. For example, learn now comprises all the different forms of learning and so on. But it makes some stuff that we do not want to have. For example, Google, maybe there could be some Googles and so on. That's too short for us. But there's another thing that could be nice to use. That's the lemmatizer. And here it's not doing these calculations from the grammatical perspective, but it's looking the WordNet corpus and using only words that are also in this corpus. So this gives us a very nice list of words. So, and then we can, of course, these are some very nice APIs. We could use a concordance for different words. So we see where in the titles code is used or user is used, and it gives you also some kind of a context, so you can read through these papers very nicely. You can find some similar words just with text similar, for example, code. Code is similar to automata, citations, classes. Sometimes it makes sense, sometimes not. And then, of course, you can do some kind of a frequency distribution. This is just the basic things. And then you can download also the abstracts. And now you can do some more sophisticated stuff, for example, to find out, of course, the important authors and journals. But then also you can take a look at the time series. So what's happening over time? Of course, 2014, there's been not so much publications, so many publications, but they of course, I think there will be a lot more. So this is interesting how it evolves. And I'm just going a bit further to doing, you can find you can cluster the content to find out which abstracts are really related to each other, and then calculate a cluster diagram. So this is, of course, this is a lot of papers, but it's here the hierarchical cluster analysis. So you find out which articles are together. It's a kind of a unyieldy representation, but for example, it also finds out which papers are being changed or being cataloged twice in the catalog. Einmal with this, first time with this title, and then with this addition, Semantic Web Challenge. So there has been an update or so. You find this. And you can also do it by the words. I did this. And here you see some of the most important words used at Google research papers. And of course, large scale is very closely related, but it's also related to image, for example, or mobile user graph. This is something that goes together very well. Or of course, language modeling, speech recognition, information retrieval. So you get a really nice impressions of which topics belong together, and of course, then you can do some k-means cluster analysis to find out which topics have similar abstracts. This is the other perspective, and for example, this is what you get from the I think it's the purple ones. They're about blogosphere, Google search, gray code. So this is actually, it's a hack, but you can take a look at the notebook and find out what you can do with this. And then, of course, to find out which topics are trending, you can compare, for example, all the words that were in 2014 that were really frequently used, and compare them to the baseline, to all the other years. And here, for example, if you're just doing this comparison by the normalized number of words, you find, for example, the symbol here. It's been used 5 times in 2014 and just 1 time before, but actually these are very low numbers, so we want to look at a certain threshold of maybe at least 10 or 20 mentions, so not the very small words. So you can find some trends, for example, that quality has been losing. This is the perspective backwards. So quality has been a very huge topic. Or it's increasing. So this is the relative. There have been 92 mentions of the word quality in the abstracts in the last 5 years, but 27 alone in 2014. Online is obviously also a hot topic, and state method research. So you can just find some interesting topics, some words. You could do this also for the bigrams, which are increasing. So you can take a look at how the different research topics are evolving and find out things that are trending. The second example is really quite another subject. It's about location trends in Foursquare. Who of you is using Foursquare? Okay, 2, 3, 4, like this. So they have an API, so where you can get some data. You cannot get data for individual check-ins, but just for aggregated results. But this is also interesting. You can give the API one location, and then it gives you the 5 locations or the 5 venues that are following very frequently. And you can use this recursively. You can take these venues and find out which 5 venues are following after this venue. And so you get a really nice network of different locations. And this is the code that's doing the crawling until we do not have any next locations. So we have got all the things, and then we're generating a network. This is obviously for Munich. I just gave it 2 or 3 locations as a seed, and then to find out from the central station, for example. So this network will be based on Munich, and then we can calculate the different network analytical numbers. For example, we can count which locations are very frequently connected with others. And we can use also the other values, for example, the betweenness centrality, that is which node is a very frequent connection of the shortest path between other nodes, or the page rank. That's the same that Google also used. So that's especially interesting for location data, because it could be interpreted as a random walk through a city. So if I drop someone on some random node, and it's going from node to node by this Foursquare network, where will she be going through? So this is the page rank. And if you calculate this, it's very interesting. You have the locations by number of users. Then there's the airport, of course. It's by far the most frequently used location. Then the Marienplatz in the city center, then the central station, then the Hofbräuhaus. So these are the locations that have many users. But then if you look at the check-ins, yeah, it's the Hauptbahnhof, the central station, it's even further. But if you look at the page rank, so this method, where would one land if one was walking randomly, then the central station is not important, because people are checking in there and then they're kind of disappearing or popping out somewhere else because they're traveling by train. And then we have the Marienplatz in the center, the Hofbräuhaus, the Apple Store. It's really a very important location. And what we can do then is kind of generate a network map to find out how these, what's the kind of the topology of the locations. And this mirrors a bit the geographical location, but not always the same, because some things are related in the Foursquare world and they're not related geographically. For example, if you do not filter for location and you take a look at Munich, I did this, and then I had from the central place, the Marienplatz, I had to take 2 steps, and I was in Old Trafford, for example. I was and also the Piccadilly Circus in London. So it's actually just 2 hops away, because there was a time of the Champions League soccer matches, and many people checked in Munich in the Allianz Arena, and then checked in some football stadium in the UK. So it was really quite nice mixture of geographical and kind of social or event relationships. And you can do this in a time period. For example, here's the network I collected it in May, and I can use these numbers to find out locations that have been rising in the different metrics. For example, those are the locations that have the largest increase in the number of check-ins. There's the Hirschau, there's all places that are outside, because in July it's more warm than in May. So people went outside, and the soccer locations are not that important anymore, because Champions League is over. And here we have the increases in betweenness centrality. We also can find new locations this way. And for example, there's a kiosk at the bridge in Munich that's losing in terms of betweenness. So you can also find out which locations you don't have to go if you really want to experience the city. And then finally, you can do some kind of a heat map. This is, of course, the airport. So it really it destroys the whole image. So I'll exclude it then. And so this is the kind of the change in the number of check-ins. And then you can also take a look at the betweenness. So here it's the soccer stadium in Munich, where there were a lot of matches of the World Championship, the public viewing. So this obviously rose a bit in this time. And here it's kind of the page rank change. And this is quite hard to look at. So we can plot it on an open street map, and then we can find some areas that are really hot in a city. And the nice thing about this approach is you don't have to know anything about a city. So you can really, if you're visiting some city somewhere, you can use this notebook to find out really the places where you have to go, and you can even start talking with locals and say, well, you don't go to the kiosk at the Reichenbach Bridge anymore because it's not hip anymore. So you really can find a nice way to talk with the people. So there's also a third notebook that's about the conference proposals, but you can take a look at it. It's basically a quite similar approach with text mining and to find trending words. This is about big data, and here it's, for example, some kind of the Strata conference topics, which topics are increasing, and you can use this to find out, for example, which programming languages are hip, or which words are, which topics are associated with Python versus R versus Julia, and so on. So you can also use it for topics where you don't know anything about. You can use it for some kind of physicists or something conferences, and you can find out what's happening in this field without knowing anything about it. So it's a danger zone, but it's interesting place to be right now. So thank you very much.
Are there any questions?
Sorry for the long walk. I've just one question. You mentioned briefly that you do this thing for the fashion industry. And in general, I would be interested in how you do this in, well, topic areas where you don't really have words to describe some concepts. So if there is a certain, let's say, cut or a certain color that will be popular in fashion, it will be quite hard to describe for just saying that something will be, let's say, pink is the up-and-coming color. It doesn't really describe the specific clothing that you would get. So how would you go there if you don't really have text data, because text data can be quite limited available?
Yeah, that's really a very interesting question, because when I was doing a lot of social media monitoring and analytics projects for various industries, it was always the thing that the clients wanted, but no one could deliver. That is how to find stuff you don't know it exists and you don't know what words to describe it with. So it's like the Donald Rumsfeld, these unknown unknowns. They are very interesting. And I think one of the approaches that can be really used is a kind of iterative process in looking at or in identifying people who are deeply connected to a topic. For example, in fashion, it's quite easy to find fashion bloggers worldwide. So you can really they have their blogs, they have Twitter accounts, and you can take a list and make a list of all these accounts, and then you're reading or you're collecting, for example, the tweets these people are writing, and then you can get some other topic areas. For example, you get some. You're looking at the results for the hashtag search for soccer and politics and so on Twitter. Then you have 2 data sets. One should be kind of fashion related and the other should be not fashion related. You can train some machine learning classifiers on these data sets. So in the end you have a classifier that really says, well, this is a fashion tweet or this is a fashion text. And then you can use this classifier on a larger data stream, such as the Twitter data stream or streaming API, and then you find fashion content by people who are not in your list right now. So you can put them in your list and you can also give them some kind of a weight. And then you look at the content they are generating. And so this is kind of various iterations. And then basically you get a lot of data about words that are normally not there, but now they are here. And those are the points where you should look at. But then it's, of course, to really bring in the topical knowledge. That's something a machine learning system or a data scientist cannot deliver. And it's really about the people who are writing the articles or the designers to have their conclusions on the data. But it really gives you these kind of weak signals, and a lot of these weak signals could be quite hilarious. But some of the weak signals are very interesting. So it's basically some kind of a precision recall problem on another stage. And there's also a very nice IPython notebook on building fashion classifiers. So I can, maybe you know it already. So, I can give you the. Yeah, it's very nice.
In case there are no more questions, let's thank Benedikt again.